All right, here we go with 1.7, which is the last section of your first chapter, and it deals with what we call composite solids. Now, any composite, if you talk about a composite material, it means that it's made up of more than one type of material. A composite bike is a mixture of different alloys, or an alloy is a composite because an alloy is defined as being at least two metals, two or more metals. So a composite means that you have more than one thing together. So that's essentially what constitutes. This is more than one, made of more than one object. Okay, so a composite solid is made of more than one solid. And an example could be simply, we've looked at these before, okay? There you go, that could be a house, you know, you got a rectangular prism on the bottom and a triangular prism on the top. It could be something that looks like this even. It could be a pyramid on top of a box. It could be a hemisphere on top of a cylinder. It could be a variety of different things. So it could be a cone on top of a cylinder. These are all composite solids. So what you're going to have to do is find the area or volume of both and then add them together. Now there's certain places that won't be added to, say, surface area, because you can see the bottom of this hemisphere and the top of this cylinder are squished together, so you don't include those places. You don't include the top of this cube and the bottom of that pyramid. You don't include the top of the cylinder or the bottom of the cone. So there's a bit more to think about when you're doing these. And you might look at these shapes now and realize that you have to remember a few things. So what I'm going to do here is quickly ask you to remember about a rectangular prism. Okay, that's essentially a box. And if we draw one up here, we can look at how to find, let's go length, width, and height. Hopefully you'll remember that the volume of these things is equal to the length times the width times the height, right? 1, 2, 3 dimensions. The surface area is a little trickier, but not really that hard. Okay, what you got to remember is that you have 6 sides. You have LW, you got the top and the bottom. You got LH, that's front and back. You got WH, that's right and left. So we have 2 of each of these. I don't care what order you put them in. I'm just writing them down, making sure that I get them all. So length, width, height. How about length, height is the last one. So 2 times the length times the height. There we go. So that's the surface area for a rectangular prism. Triangular prism, a little bit different. If you want a lesson in that, you just find the area of the triangle and then multiply it by how deep it is. The problem is that there's lots of different triangles, and all you have to remember is that it's 1/2 base times height. You won't see that one that much right now. Okay, what I want to focus on is a cylinder, which is another shape that you have recognized, but you might not remember exactly how to find the surface area. Okay, so the diameter is all the way across, the radius is in the middle, and this is the height. Okay, so even if we drew it differently, say this way, okay, this is still your radius, this is still your diameter, and this could be considered still your height. Okay, it's just on its side, it's a little bit different. One thing we have to remember, okay, you have to recall the circle. In order to solve these, you have to understand the circle. We've dealt with it already when you're dealing with cones, okay? But quickly, let's just run over it again. The diameter, right, is all the way across, and the radius is from the center to the outside. So R is equal to what we call the radius, D is equal to what we call the diameter, and there's a relationship, D is equal to 2 of these R's, okay? Now, if you want to find, there's 2 things that we find with circles. We can find the area of the circle. So the area is equal to pi r squared. All right, that's the area of a circle. Now the circumference, which is all the way around, it's like the perimeter of the circle. Okay, it's all the way around. That comes out to be 2 pi r. Some people look at pi d. Okay, why are those the same? Well, it's because 2 times r is equal to d. okay? So that's what we need to know about circles. So the volume of a cylinder, okay, is pretty easy to do. What you do is you find the area of the circle and then multiply it by the height, right? The area of the circle and then multiply it by the height. Or the area of the circle and multiply it by how long or how deep, whatever it is. So the area of the circle is pi r squared times the height. Boom. That's all you do for the surface area of a cylinder. Okay? Or sorry, the volume of a cylinder. The surface area is a little bit trickier, and I'm going to go on to this next page and show you. Okay? Because if you look at a cylinder, boom, 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 on any cylinder, right? If you cut it down here and unfold it, you'll see that it looks like this. It's going to be a big rectangle, right? And then you're going to have the top lid flopping over and the bottom lid flopping over. And that's what we call the net, right? So here, that's my R, here, that's my R, this is my H, that's my H. What I need to know is how long this rectangle is. And I don't know if you can see it, or if you can understand it, but this length right here is the same as the circumference of this circle, because it actually has to wrap up. And if you take any piece of paper, look at this, when you roll it up, right? When you roll it up, that's that cylinder there. You've got so when you unfold it, boom, you have the rectangle. So this length right here wraps around the cylinder. So the whole length of this is your circumference, which is 2 pi r. Okay? So now what we do is the surface area is the area of the top and the bottom, 2 pi r squared, right? Top and bottom. Plus here, this is 2 pi r times h. Length times width. This is the side. Okay? This is top and bottom. There you go. That's the surface area of a cylinder. Okay? So now, I can give you a couple of examples here. Let's look at a cylinder with a cone up top. Okay? I will have the cylinder as being 10 high. I will have this as being 10 here as well. And we'll make the diameter, will make 6. Okay? So let's find the volume of this thing. So the volume will be the volume of the cone plus the volume of the cylinder. Well, the volume of the cone, okay? Let's look at the volume of the cone. That's going to be pi r squared times h divided by 3. We have the r. What's the r going to be? Right? R is equal to half the diameter, so 3. And then your height will be what? Well, if this is 3, and I don't have the height here, what we have to do is Pythagoras. So let's go over here and do this. It's going to be 3 squared plus h squared is equal to 10 squared. So that's going to be h squared is equal to 100 minus 9. H squared is equal to 91. That means that h is going to be the square root of 91. Let's just check that out, the square root of 91. And you get 9.5. So h is 9.5. Here we go, 9.5. So I got h is equal to 9.5. And now, no problem. Pi r squared, so pi times 3 squared times 9.5, all divided by 3. So let's have a look here. We'll finish it up. So it's 3 squared is 9 times 9.5 times pi enter divided by 3. I get 89.5. Okay, so the volume for that is 89.5, whatever it is, units cubed. All right? And then we do the volume. And then we have the volume of the cylinder being pi r squared h. So pi r squared is the bottom. That's going to be pi times 3 squared. And then the height of the cylinder is 10. Remember, you have to use the height of the cylinder now, okay? Not the cone. So this is going to be 3 squared is 9 times 10 is 90. That's 90 pi. So 90 pi is equal to 282.7. So your total volume is equal to, right, here we go.